All right, folks, in this lab, we'll try to design a ARM templates which deploys a scale set connected to a SQL Server backend to serve as a website. To start that process, we'll start Visual Studio. We'll create a new project. From the project template, we're going to go for the cloud under Visual C# and select Azure Resource Group. Now, the skill set allows the dynamic expansion of capacity by adding additional virtual machines. Now, consequently, as the virtual machines are being added to the skill set, there will need to be a set of Powershell Dsc configuration being applied to these newly added nodes. Now, we can look at Visual Studio templates as well as a bunch of other things that you can get from GitHub. For now, we'll start with virtual machine scale set. Now, this will give us a starting point that contains the scale set resources. Now, when you open up the JSON template on the left-hand side, you will find a JSON outline whereby you can quickly navigate to the different sections in your JSON documents. As you select the parameters, what you have selected on the left is now highlighted in the JSON document itself. All right, and here we have a VM scale set. To configure this using the DSC, we're going to add a new resource. One of these resources will include running a custom PowerShell or Bash. You'll have one for standalone VMs, like custom script for Windows extension, or custom script for Linux extension. These are for single VMs, and there are also scripts for VM scale set. Now, the one we want to use here is specifically for PowerShell Dsc. So here is the desired state configuration. I'll create an extension called Cloud Shop and add to the project. And you'll see on the project folder, there's now a PS1 where we can specify the desired state configuration. Now with this PowerShell configuration, we're going to paste over the resource given as part of the lab exercise in your lab VM. There is a obscurity folder that contains scale set extension code. Now, this code is copy and pasted into the cloud shop.ps1 that you see here in the middle of the screen. Now, this configures the local host, most likely which will be our scale set, to include an IIS feature to make sure it's installed if it's not. Also include ASP.NET 4.5. Now, our script will take a parameter called deploy web package. Now, that web package will be hosted on GitHub under this URL, under Azure Readiness, Microsoft Azure Training Kit. There's a hands-on lab, and you will find the location of the cloudshop.zip. Now, if you're looking for this, just Google cloudshop.zip. You will land right here. Now, what you'll need is feed this URL into the DSC. So when the server comes up, it will go out, grab the zip file, and let's see what happens. Okay, so here's our PowerShell script to go ahead and download the zip file to the C drive of the machine we're trying to configure. Make sure our www root is cleaned up by calling a remove item. Now here is our PowerShell command that downloads the zip file. this extract what we downloaded into the root, which configures starter websites. This part of DSC copies from c:\web app into the inet pub. Okay, and this makes sure that deploy web package is indeed completed. Now I'm going to make a quick fix here because the extract to directory should be extracted stuff into the web app. And notice it depends on the script deploy package to succeed. And the result of our script is to put the extracted zip file into the web app. So when this DSC is being configured by the DSC subsystem on the scale set, it will make sure the roles and the features are installed, package downloaded, extracted to c:\web app, while our file copy activity will copy from c:\web app into www root recursively. Now next, we're going to do some network adjustment in the JSON templates. Now you notice our virtual network at the moment contains one subnet. Now we're going to create a subnet 2. So we're going to add a comma here and make sure we duplicate this section. Now we'll be looking out for a variable called subnet2 name, which will be a variable that we need to create. So notice the red wiggly line that will need to go away in a moment's time. So we're going to have two variables representing subnet 2. So in the JSON outline, I'm going to navigate to my subnet configuration. So on the left hand side, let's look for the subnet names and subnet prefix. So these are the two variables we need to make changes, or in fact adding an additional one. So subnet 2 prefix is going to start at 10.0.1/24. Our subnet 2. So this is where we can give it a name. So our subnet 1 shall be called web, while our subnet 2 should be called SQL. So duplicate this element and create a subnet 2 that's called SQL. Alright, so now the variables configured. Let's review the network. You'll notice the red wiggly line goes away, squiggle, because the variable now exists. All right, now that we have configured the virtual network, we're going to turn our attention to the deploy cloud shop PS1. Now, this is, again, the DSC. If you recall, our DSC expects a parameter of the web deploy package. So we need to make sure the variable is present in our template. So here we're going to copy and paste this element, web deploy package, now into the variable section. So using the JSON, I'm going to navigate to the last of all the variables. And I'm going to paste over the URL from the GitHub. Now make sure you copy it directly from the download link. So notice I'm going to copy this link location, and you'll notice that when you paste this or go straight to that location, it should begin a download, okay, that contains your site contents. So with that on my clipboard, I'm going to stick that in there. Now with this variable in place, let's take a look at how we associate the DSC with the scale set. So to find that out, let's navigate to the scale set resource within this template. In this scale set resource, you will find that there is an extension called DSC. And notice there's an extension profile that includes how to gather the diagnostics. So for now, we'll ignore that. That's the first of the extensions. Now, the second extension is the Powershell Dsc. The settings will be fed into our cloudshop.ps1. So there is the URL. Okay. So what we're trying to do here is to make sure that we feed in both the node name as well as the web deploy package expected by the DSC. So let's take a look at the PS1 again. Notice the parameter section in this configuration expects a node name, which is already configured in the JSON. So the only thing that's missing at the moment is the URL for the web deploy package. So what we're going to do here is to copy this configuration arguments and add a new one. So this new configuration argument is for the web deploy package. Now we don't need a $sign here because this is not a PowerShell, this is just the parameter name. Now here we needed to pull from our variables. And our variable name, just to quickly reference, make sure I don't make a typo here, is the web deploy package. So that's the name of our variable. Okay. All right, so there you have it. So this configures the input to our DSC for our skill set. So at this point, our web server tier is done and to be configured by the PowerShell Dsc. We're going to move on to deploy the application database. Now in this exercise, we're going to have our SQL server along with two additional VHDs, disks, which involves creation of a storage account and placement of a SQL VM. Okay. All right, so let's go to our template. Let's add a storage account to house the SQL VM. So we're going to click on the icon, add resources. We'll choose a storage. Now keep in mind this template as you add your storage account. The name will come from a variable cloud shop name, and when you look at the variable, notice the variable cloud shop name contains the prefix that you choose plus a set of unique strings. So try not to make the prefix too long. There is a length limitation in number of characters you're allowed. So this will be a relatively long string. So we don't want this to overflow the name. So we have a storage account. Let's go ahead and add a new virtual machines. We'll be running SQL Server on top of a Windows machine. So we'll select the cloud shop and we'll put this in the second subnet. And we'll call this SQL VM. this. Now this is not going to be a standard Windows VM, so we need to configure the VM image offer and the publisher accordingly. And I'm going to be using the instruction. So this is our image publisher. And our image offer will be SQL Server 2014 on Windows Server 2012. Also, we will delete the parameter called SQL VM Windows OS version because we don't need that. And let's go to that parameter and get rid of it. All right. Because we don't need to solicit user, we are hard coding that into our image offer, so we don't need to present that as a parameter for the users to choose from, so we're deleting it. Okay. We're going to add, however, another parameter called SQL VM SKU. Now we will allow users to choose between standard and web edition of the SQL VM. So this is the parameters, and I'm going to add another parameters here. I just want to clean up some of these empty spaces. JSON doesn't care about empty space, it's just that it doesn't look odd for me. So next, we are going to the VM in the storage profile to change the reference because we deleted the parameters, and we want to change the SKU to the parameter we just created. Okay. So let's navigate to that. SQL VM. So we're going to change this to the web or standard based on users choosing. So our parameter is SQL VM SKU. Okay, so that is the name. If I can copy and paste, that will eliminate the possibility of having a typo there. So again, in the storage profile, there you have it. So this will get the image straightened away. Now here we're going to create two variables for two additional data disks on the SQL Server to house our data files that we'll be restoring from. So let's go to the variables and create these two additional variables that points to the SQL storage. Now remember, this is a variable. Let's append to it. So this is the end of all of my variables. So I'm going to add a comma before I add these two additional elements. I created a storage earlier, so that's the one I want to use. So the variable is the storage account. So the cloud storage account I created for the SQL Server is called is on the variable cloud shop name. Remember, we created this right before we created the SQL VM. So that's the variables. Just want to quickly double check. That's called cloud shop storage, or cloud shop name. That's why I couldn't find it. So this is the variable that we are going to use. In our SQL disks. So that will be combined with .blob.core/VHDs container, and we'll create two VHDs. disk 1 and disk 2, and the variable that points to URL is called SQL disk 1 and disk 2. So now we are going to go to the SQL Server VM and go to the storage profile, make sure those two VHDs are attached as data disks. It has an OS disk out of the box. Obviously, you need to have an operating system for your SQL, but we need two more for our data disks. Now I'll be switching over to the lab instructions to copy that element into what you just saw. Paste that there. Okay. Now quickly, the data disks is made out of two disks, 1 terabyte each. The LUN specifies the order of discovery, so your operating system will see data disk 1 first, followed by data disk 2. So think of them as the SCSI LUN, so you control exactly how the operating system discovers it. And notice our operating system supports caching of read-write. Now, if you like to control the caching, it's quite common that if you're working with a relational database that you do not enable any caching on your data disks, because, well, if you cache that and the machine goes out, you wind up with a corrupted database. So here, just on the safe side, we'll keep the caching to none. Okay, we certainly don't need to double cache it. SQL Server has a buffer manager that caches stuff already, so there's no reason to double cache it. So I'll set the caching to none. Now, because our SQL Server VM is a standalone VM, we'll be adding a PowerShell Dsc configuration to the VM. So by going to JSON outline, click on Add Resources, and this time I will be choosing, scroll too fast, PowerShell Dsc extension. And I'll call it SQL Dsc. Now in my Solution Explorer, I will have now a SQL dsc.ps1 that I need to fill in to configure the SQL Server. Now again, I'm going to go into the lab VM where I can find OpsAgility folder, SQL extension code, and I'll be copying this into my desired state configuration. Now just a quick review. Again, our DSC requires the node name, which will be localhost, that's fine. Now we also need a web deployment package. Now this desired state configuration will configure a storage pool using the two disks. Actually, we'll create a storage pool covering all the physical disk that can be used, and essentially create a storage pool. So we'll create a new virtual disk on top of that pool using the maximum size. Initialize the partition, essentially format it with NTFS. So there's that step right there. Wait for 60 seconds until the format completes. Specify the parameters for the log file and the data file. It looks like they'll all be on F drive. We're using storage pool after all. We'll go ahead and create these directories that necessary, and the C:\SQL data. And we will be importing SQL PS PowerShell module in order to run some PowerShell script. Okay. So this is instantiating a new SMO object to manage the SQL Server. Creates all these settings. Okay. Restart the SQL Server service. Invoke SQL command to run the script against the master database. Enable the SA account, and the password is demo at pass1. That's our SQL database password. Now I'm going to go on and find eventualworks2012.back. Actually, I'm going to click on it to make sure this is actually alive or not. Okay, so it looks like the URL is alive, so I don't need to make any changes. Now, when you do the lab, if you click on that link, it's not there. Try to find eventualworks2012.back somewhere on GitHub. You'll find one in a GitHub. Okay. All right, and this will be downloaded to C drive, SQL data, eventualworks2012.back, and the invoke web request simply downloads it. All right. Now we're going to use SMO to restore and relocate the data and the log file to the F drive that we have prepared. Restore SQL database. Sets a firewall rule to allow 1433 on the server. So this firewall rule controls your Windows firewall. This is not your NSG. This is not anything Azure related. It is just a Windows server that to handle 1433 inbound. So this is just that. All right, so I think that's the gist of this PS1. So it looks like everything is in order. We can try to continue on with the next exercise, which deploys by right-click on the project, select Deploy, New. Now this is where we pick the subscription the lab generates for you. Tab over to my lab environment, where I can find my username. And the associated passwords. I think I missed one of the letters, perhaps. All right. Now we'll be deploying to a new resource group. Let's call it Scale Set RG, and let's deploy this to East US. Now in the edit parameter, this is where we supply the VM scale set name. Instance count is 1. That's my SQL name. Now I can choose to save the password as plain text inside the parameter file. Now, to store these credentials safely, you can click on this lock icon to pull the password from a Key Vault secret. If you click on that, you'll need to specify which Key Vault and what's the name of the secret you're trying to pull. And this will make a reference to that Key Vault. I'm going to save that, and I think I'm ready to give it a try. Now I'll be pausing this video for a moment until this finishes. And behind the scene, you'll notice in this output window, it's effectively running this deploy Azure resource group.ps1. So if you're interested, you can follow the steps or troubleshoot from this deploy Azure resource group.ps1. Now what's going to happen is this will be presented to Azure, and it will take somewhat about 10 minutes to have everything ready. So I'll pause that, then we'll come back. So while waiting for this deployment to complete, I'm going to move on to the next exercise, which adds an Autoscale resource, which defines the minimum nodes and the maximum nodes of my resources. I'm going to go to the Visual Studio. While this is deploying, I don't certainly have to wait for that. I will go straight to my templates. So in the Solution Explorer, go to the JSON file, and I'll be adding an Autoscale resource. So go to JSON outline. Now if this window disappears, go to View, Other Windows, and you can bring back the JSON outline. If you don't see anything in JSON outline, make sure you have a JSON file in focus in your text editor. If you're not focused on the JSON document, this outline will have nothing to show. So I'm going to click on New Resource, Add Resource, and I'll be adding an Autoscale resource for VM scale set. I'll call this Autoscale Web. Click on Add. Okay. Now in that Autoscale, I'll specify a minimum and a maximum capacity. default being 1. Now I can control what is the condition. So if the average for within the last 5 minutes has CPU average on the scale set greater than 80, I will be increasing the VM by 1, and it will wait for 5 minutes until it starts to monitor the usage again. So if you want this to grow before the 80%, you can change these thresholds. All right, so go ahead and save these rules. Okay. Now you notice there's also a trigger. It's not uncommon to have a complementary pair rules. So rule number 1 scales up when it's over 70 and scale it back down when it's less than 60% usage. So usually you probably wouldn't have this window so narrow. So if you have a 70, you're probably looking at a 40 before you scale it down. Okay. There we go. And probably the time to wait 5 minutes before you take another instance out of the scale set. All right, so you'll see that this project is source controlled on GitHub. Okay, and I'll be pushing the change to the GitHub. There you go. Now to find GitHub, this is on my repository, which will be github.com/Victor Chin. And you'll find a repository called Victor Chin/Opsagility, and you'll find the scale set project in this folder. And you can look at the various commit histories to see the JSON documents. So this is the current version with the Autoscale set. You can look at the history version without it. Okay. Adding Autoscale and complete templates for your reference. All right, so this concludes the lab exercise. If you wait long enough, you'll see all these resource gets provisioned. As provision succeeded, and you'll see that the extension is running. Okay. And this output is going to check every 5 seconds until everything comes back, either yay or nay. You'll find a bunch of storage accounts being created in preparation of scaling up. So these storage accounts will be accommodate your scale set. Now, one more thing before we move away from this. Keep in mind that anytime you have a scale set, there will be a load balancer sitting in front of your virtual machines, where your backend pool is your scale sets. Okay. There we go. So our backend pool is referencing the variable BE pool name. These are all part of the VM scale set out of the box templates. So you didn't actually have to create any of these. Okay. But as soon as you add a scale set, a load balancer, a public IP, and a virtual network is created along with that resource. So the front IP configurations are public IP address, while the backend pools are our scale sets. All right. So a variable pool name, BE pool name. Sometimes it's easier just copy and search. Okay. So here's our load balancer address pool. As part of the network profile of our scale set. So this specifies the nicknames and add the nick to the backend address pool for the load balancer to redirect traffic to. All right, so that's all the missing pieces in this template. My name is Victor Chen, and if you have any questions, feel free to send me an email, Victor, email. All right, send me an email if you have questions.